Hello, Math 141. This question was emailed to me. Find the polynomial of degree 4 that satisfies the given condition. Degree is 4, so that means that the highest degree is 4. Zeros are -1, +1, square root of 2. The fourth root is not given to us, so let's see what we can do about that. And it has integer coefficient, so I have a number, not a fraction, in front of my x to the fourth in the beginning. That's what it means. And the constant term is the last number is 6. So I need a 6 at the very end. Okay. So let me go to the next page. If the zeros are given as -1, +1, square root of 2. From the first one, I can say, well, if x equals to -1, then I have x plus 1 equals 0. That's a factor. If x equals to +1, then x minus 1 equals to 0. So x minus 1 is another factor. Using square root of 2, I can say if x equals to square root of 2, so x minus root 2 is another factor. So, and listen, the fourth one is not given to us. What do I see here? I see something to the fourth degree, which is pretty much the graph is going to be something like this, or something like this, some fourth degree. Okay. It's symmetrical about the about the y-axis, okay? And notice that here, since I have x equals to -1 and x equals to +1, so I have two roots, then I'm gonna say that, okay, if x equals to square root of 2 in here, then I can say x equals to -√2 as well, to give it that symmetry. So this one results as x plus square root of 2 equals to 0. So now I can claim that f of x equals to x plus 1, x minus 1, x minus root 2, and x plus root 2. So this equals, so f of x equals to x plus 1 times x minus 1 gives me x squared minus 1. And x minus root 2 times x plus root 2 gives me x squared minus 2. Okay. Now, f of x equals, now f of x equals to x to the power of 4. Then I have minus 2x squared, another minus x squared gives me minus 3x to the second, and then plus a 2. Okay. Now the author is saying that the constant term is 6. So this 2, I want to turn this into a 6. So I'm going to multiply everything by 3. So f of x equals to 3x to the fourth minus 9x to the second plus 6. Now, the key to this problem is in the beginning, okay? Let's look at the original question. Whoever person that designed this question is saying find a polynomial, not the polynomial. Find a polynomial of degree 4 that satisfies the given conditions. The degree is 4, has zeros of -1, +1, square root of 2, has integer coefficient, and constant term is 6. And as you can see, the polynomial that we found does satisfy this condition. it has degree of 4, it has an integer coefficient, in this case 3 right here, okay, and the constant term is 6, just like what the author wanted to for us to find. Okay, so once again, what logic did I use? I used the fact that f of x equals, if it's x to the power of 4, okay, it, if it's not shifted too far to the left or right, it will have symmetry in relation with the y-axis. And it told me like, you know, well, two of the roots, if -1 and +1, okay, they're symmetrical in relation with the y-axis. So therefore, I'm given square root of 2. So I'm also choosing the opposite of that, minus root 2, to be my fourth root. I hope you enjoyed this example. Thank you.